Hello everyone, welcome to 369 Chemistry, and today in this video we are going to do that one topic which is also a name reaction, that is called your noble condensation. Okay, so this is a condensation reaction. Okay, that means some molecules or some reagents will combine to each other to to come in a form of a condensed compound. Okay, so some molecules will be removed, there will be some formation of some condensed compound. So what is it? So the condensation, you can write the definition of it. Just write it down as it is in the copy, so you can write in your examinations. Okay. Condensation. Condensation of aromatic aldehyde. Okay. Aldehydes. I can write it. It goes for aromatic as well as aliphatic one. So condensation of aldehydes and ketones with compounds having active methylene group. Okay, so this is important. What is this called? Your active methylene group. So this one you should know first, then only you can proceed through this reaction. Okay, methylene group, and it is done in the presence of, okay, in the presence of your basic catalyst. And we will also see the mechanism of it. Okay, so we will use the basic catalyst in this reaction. Okay, to form, what does it form? To form your alpha beta unsaturated compounds. To form your alpha beta unsaturated compounds is known as Noble reaction. Is known as your Noble reaction. Noble reaction. Okay, so the basic catalyst may be ammonia or its derivatives. Okay, here the basic catalyst, basic using, it can be ammonia or derivatives of ammonia. That means something which is derived from ammonia, that is ammonia, or you can say derivatives of ammonia. So let me see, give an example. So see here, suppose this is an aldehyde. Okay, and you have COOC2H5, COOC2H5. This compound is called your active methylene compound. Why? Because it has very much acidic hydrogen. See, this hydrogen is too much acidic because this carbon, these are very much electronegative. It will, this oxygen is going to pull the electron, and this one is very much reactive. And this hydrogen, usually it wants to go out very easily. So this is called your active methylene compound. Active methylene compounds. And why it is active methylene compound? See here it is CH, is it not? This is a methylene group. That is one carbon. On these carbon, the hands of these two is substituted by the, this C double bonded O, OC2H5, C double bonded O, OC2H5. So this is, you can say, esters, right? So here, so these two hydrogen becomes very much reactive. So this is called your active methylene compound. So it is done in the presence of pyridine, okay, done in the presence of pyridine. And then what we get is this. Okay, that means this is adding to this and giving you a compound, that is your alpha beta unsaturated compound. So this is the reaction. Now we will do the mechanism of it, and then we will discuss about how, what are the factors, that is responsible for good reaction of this, and what are the factors which is unfavorable for this reaction. We'll discuss all. So if I write the general formula, this I have given with an example. Okay, so if I write the general formula, it is like this. See this. this is an aldehyde or a ketone. Okay, so H2C. Okay, this is X and this is Y. That is two electronegative groups, whatever it is. Okay, in the presence of a base gives you R dash double bond C, then X and Y plus water. Okay, here R dash, okay, is equal to H, or you can say it can be R, that is alkyl group. Okay, or it can be aryl groups also. Okay, and X and Y, these are two electron withdrawing group. If it is not electron withdrawing group, then then there is no problem, then active methylene compound will also not form, right? So you need two electron withdrawing groups. Okay, and it can be example, like it can be different also, not just that, it can be your this aldehyde also, COR also, COOR, then cyanide, then nitro. Okay, then you have SOR, etc. So these can be, okay, the order of the activating effect of the methylene group. I'll write this, that is NO2 is more, because this is more electronegative than cyanide. Then comes your COR, then comes your COPH. Okay, so this is the order of activating effect on the methylene moiety. That means the methylene moiety which we are using here, the groups, it can be anything. It can be your this NO2, CN, COR, and COPH. So if these groups are there, these groups, then what happens? It is more activating. That means the hydrogen will go out very much easily. So active methylene compound will be formed more easily than these compounds. Okay, so this is also one of the important thing which I wanted to discuss. So now we will start with the mechanism of it. Okay, so what we will do, step one, write it down. Step one, it is the base removes the proton. Okay, the base removes the proton from the active methylene compound to form a resonance stabilized carbon atom. Okay, to form a resonance stabilized carbon ion. Okay, so this step is this one. See, this is the base, right? This is the base. It is and this is the compound, right? The active methylene compound. So it is going to take up your hydrogen, and it is taking up the hydrogen from here, and now what it is going to form, it is going to form this. Okay, so this compound is going to form, and this one is resonance stabilized. Why resonance stabilized? See here, it can go here and form this, so it can be formed like this also. See, HC, okay, double bond C O minus O C2 H5, C double bond O O C2 H5. So there is a resonance stabilized kind of product is forming in this case. Okay, so this is the first step. Second step, step two. Okay, the carbon ion now attacks the carbonyl carbon. That means the carbanion, that means the carbanion intermediate which is formed, this is the minus intermediate, carbanion, anion intermediate. Okay, so this one is going to now attack, okay, the carbanion, then attacks the carbonyl carbon to form to form your alkoxide. Okay, so what is the alkoxide which is going to form? See, check, this is the aldehyde which had benzaldehyde. Now this, okay, so this is going to come and attack out here, and you are going to get this as the product. Alkoxide, you are going to get H, okay, O minus Now comes your C. Here it will be H. Okay. Then you have C double bond O, OC2, H5, C double bond O, OC2, H5. Okay. Now in this step, what happens here in this step, this oxygen O minus, okay, what it will do, it will take, the what was the base which was formed above, right? It is going to take up the proton from this base, okay, which was formed in the first step. There is this one also, which I did not mention, but this kind of intermediate is also thrown out while forming the carbonyl. So this is the done. This step is, did you understand? Now what will happen? It will take up, I'm not just showing writing by step. Now I'm just I'm just going to show you this. So here, this one, now here it is OH, here it is, this is CH, C, here it is C double bond O, OC2H5, and COOC2H5, right? Here what happens? Now see here, this one, water molecule separates out. So if you heat this, minus H2 is formed, okay, minus H2O goes out, and then you get your alpha beta unsaturated compounds. C, okay, there is H, double bond C, then you have C double bond O, OC2, H5, C double bond O, OC2, H5. Okay, this one now goes for hydrolysis. So I will show the step of hydrolysis. So what will be the end product? We can do only after hydrolysis. So if in question it is given only to alpha beta unsaturated acids, a compound, so you give only this much, okay. But if it is said, give even hydrolysis, H2O is written there in the molecule as reagent, then you have to go for the last step, that is your hydrolysis step. This is unsaturated compound. So step 3, or the last step, that is the hydrolysis. Hydrolysis of alpha beta unsaturated compounds. Okay, so how to do this? Here, see, the last step was this, right? You have this, okay, and you have C double bond O, OC2, H5, then you have C double bond O, OC2, H5. So what a molecule is there in the reaction medium? What will it form? Okay, what a molecule is there? It is going to attack this. Okay, so after attacking, what it is forming? Now see, here it is becoming O minus, then OH, H plus, okay, then you have OC2H5. Here also you have C, here is O minus, okay, and then you have OH, plus, right, and then you have OC2H5. Just follow the previous structure so that you don't make mistakes. Now see, this O minus is going to take this one, is it not? This O minus is going to take the hydrogen of this water molecule, so you are getting this now, CH double bond C. Here you are getting C, here also it is C, here it is OH, and OC2H5, right? Here also you have OH, you have OH, and then you have OC2H5. Okay, now see here in this one, this hydrogen will come out and this molecule will go out. This hydrogen will come out, this molecule will go out. So twice C2H5 OH, is two molecules of alcohol is now removed. Minus two molecules of alcohol is removed. So your final product looks like this. It comes your alpha beta unsaturated acid. C, now C double bond O, OH, C double bond O, OH. Okay, so what happens here? Here also there is removal of one molecule again, that is minus CO2, carbon dioxide. See here, this hydrogen can come out here. That means this if this comes out here, actually this hydrogen comes out here, then there is minus CO2. This molecule goes out, then you are getting your product as this CH double bond CHC double bond OH. So this comes to be your final noble product, condensation product. Okay, alpha beta unsaturated acid if hydrolysis is done. If hydrolysis is not done, then up to step 2 you will get your answer. Okay, thank you so much. We have discussed this much. We will discuss about if there is some questions also which are important, and some practice questions also we will do in the next video.